Welcome back to chapter 2, section 2. And section 1, we talked about symbols and terminology. Section 2.2 is subsets and diagrams. So in this section, we're going to focus on what is a subset and we're going to talk about diagrams. So what is the objective of this lesson? We want to determine the complement of the set within a universal set. So a universal set is all of the potential elements of all of the sets. Determine if one set is a subset of another. We'll talk about what is a subset. Distinguish between a subset and a proper subset. Determine the number of subsets of a given set. And we want to use the diagram to depict set relationships. So we'll talk about complements of a set. So the definition of a complement is for any set A within a universal set U, the complement of A is written as A prime. So this A bar is called A prime. The complement of A, when you write it as A prime, is a set of all elements of U that are not in the element of A. So it looks like this. A prime is equal to X such that X is in that element of the universal, but not in A. So it's everything. So it's everything outside of A. So it's not any elements of A, it's everything on the outside of A. So we're going to be finding complements very soon. So let's say that the universal set is given by A, B, C, D, E, F, G, and H. M, the set M, it contains the words A, B, E, and F, and the set N contains B, D, E, G, and H. We want to find M prime. Remember, M prime is all elements that are excluded from M in the universal. So if we compare M and the universal, we want to exclude those values. So we're going to exclude A, B, E, and F. So what do we have left over in the universal set? And that's exactly what M prime is. So M prime is the set C, D, G, and H. That is M prime. C, D, G, and H. So we are excluding all of the elements in M in the universal. So we're just crossing them out. So we're removing U minus M pretty much. Similarly, we have U and we want to find N prime. So now we look at N, the set N here, and we want to find N prime. N prime is all elements excluded from N, from the set N in the universal. So let's remove those. So B, D, E, G, and H. So what elements do we have left over? A, C, and F. A, C, and F, that's exactly my N prime, or my complement. N prime or my complement. So N prime. N prime, or it looks like this notation. So that means what we're doing now is finding the complement. What is a subset? Let's talk about a definition. The subset of a set, so it's a subset. So we have A is a subset of B, so B is bigger than A. And also it's written as A is a subset of B. This is a subset. That means all of the elements in A live in B, but B is bigger. Yeah, bigger in this case. What we're going to do is, excuse me, we're going to determine if one set is a subset of another. So let's look at this. A, C, and D, A, B, C. Well, first of all, A doesn't even contain here, so B doesn't even live here. So not a subset. So this has 3 elements, this has 3 elements, but B would have to be in here. It's not. So therefore it's not a subset. 1, 2, 3, 4, 1, 2, 3, 4. Yes. This is a subset. And they're actually equal. So you can be a subset and be equal to each other. 1, 2, 3, 4, 1, 2, 3, 4. It's a subset, but they're also equal. Now let's look at this one. 8, 9, 10, 11. 8, 9, 10, 11. Yes. See how the first one's smaller? This is also a subset. So there's 2 types of subsets. A subset that can be equal, or a subset where your other, the next one is bigger. So we want to study these types. You can be equal, a subset, can also be the same set, or just a piece of it. Set equality. Suppose that A and B are sets, then A is equal to B if A is a subset of B and B is a subset of A, and they're both true. So it goes both ways. For example, B. A is contained in B, B is contained in A. It works both ways. This is equality. So for example, we had 1, 2, 3, 4 is a subset of 1, 2, 3, 4. And again, if they were in order, it doesn't matter if they are or not in order. So now what is the difference between a proper subset and a subset? So a proper subset is a set if A is contained in B, but B is not contained in A, but they're not equal. So for example, the last one, C, is called a proper. And it can look, it's this and this. It can work both. It can be a proper, but it could be a subset. So 8, 9, 10, 11, notice that that is contained in B, but B is not the same as A. So that is called a proper. And it's written in this format. It doesn't have the equality on the bottom. Okay. So it can be written this way or the other way. Now, decide whether to use, you can use a subset, a subset or a proper or both. Let's look at the first example, A, B, C, and A, B, C, A, B, C, A, B, C. They're not equal, so I can't use this, but this is bigger. The other set, A, B, C, D, is bigger than the first set. So this is a proper. So every element in A is contained, but not element of ABC is in ABC. So then this would be a proper. The next one, 1, 2, 3, 4, 1, 2, 3, 4. A is contained in B and B is contained in A. This is equality. Or you can have a subset, a plain subset. Okay. So this is how to distinguish whether something is proper or a subset or even equality. Example 4. How do I list a subset from a set? So let's say that I have a 3 and a 4. Make sure that you always begin So all subsets contain the empty set. Again, all subsets have the empty set. So we start with the empty set, then we separate them. We have a 3, we have 4, and we have a 3 comma 4. This is how you list them. Empty set, and then 3, and then 4, and then 3, 4. So you break them in pieces. Remember, the empty set will always be a subset of any set. So then you can also do trial and error. And the set 3, 4 has 4 subsets. So notice you have 2 elements. So just be careful with noticing that there's going to be a pattern depending on how many elements you have on your set. Now let's say that you have A, B, and C. So you're going to split. Again, you start with the empty set. All of them will contain the empty set as a subset. Then we break it down as A, B, and C. Then we can do a combination of A, B, a combination of A, C, a combination of B, C, and then, well, the last one is again A, B, and C because you are allowed to be a subset and equality. So you have 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets. So as you practice, you're going to notice that there's a formula on counting subsets. 2 raised to the number of elements. So in the set. So before we had 2 squared was 4 subsets. And 2 to the third was 8 subsets. This is the number of subsets, how to count. There is another way to count subsets, and that's using a tree diagram. Let's say you have A and B. What happens if A is a subset? Is it a subset? Yes. Is it a subset? No. Then you have B. Is it a subset? Yes or no? Yes or no. So either yes, yes. That means both A and B are in your subsets. If you're yes and no, that means you're only A. If you are no and yes, that means you're only B. And if you're no and no, you are the empty set. So just breaking it apart. So are you a subset? Yes or no? If B is yes or no, each have one yes or no, and then you do a tree. Yes, yes. That means A and B are in there. Yes and no, that means only A. No and yes, that means only B. And then no and no, that is the empty set for subsets. Again, how do we use the formula of the number of subsets? The number of subsets of a set n elements is 2 raised to the n, where n stands for the elements in the set. Now, this is subsets. What about proper? Remember, proper are the ones that are less than the actual, less than the equality one. So you're just removing one option, 2 to the n minus 1. So in the other ones, if we wanted a proper, we would just get rid of this option. 1, 2, 3, 4, 5, 6, 7, because these are all less than A, B, C. So 2 to the third minus 1, you get 7. So for that example, those would be the proper subsets. Let's look at this one. Find the number of subsets and the number of proper subsets. So M-A-T-H-Y, mathy, 1, 2, 3, 4, 5. We want to find the number of subsets. It's going to be 2 to the 5th, which is 32 subsets. I'm not going to list them all, but again, we start with the empty set and then M and then A and then T and then H and then Y, and then we do combinations of those. And the proper subsets would be 2 to the n minus 1, which is 32 minus 1, which is 31. So there it is, 2 to the 5th and 32 minus 1, which is 31. The last slide is to talk about Euler and Venn diagrams. Again, a diagram is a visual aid to help us understand the relationships among various sets and in identifying subsets. Both Euler diagrams and Venn diagrams generally depicts the universal settings of a rectangle. So see how this is the universe? And then A is the set. So then U is the universe. And A is the set. So then you can find that the A prime is all the way in the outside. So removing, so it's U minus A will give you A prime. And that's how we end with this section. Thank you, and I will see you in the next section.